Hello everybody and welcome to this presentation of our paper, A Code-Efficient Process Scripting Language. Let's start with the motivation. Imagine you are implementing a business process management system in a company or deploying a new process onto an existing BPMS. In order to do that, you need a model, which is an executable process model which describes the control flow of the process, the data processing, and message handling. And in addition, has to be understood by both developer, who is responsible for lower level issues like data processing, and the domain expert, who would be responsible for the business logic. So what are the available alternatives? First, there is BPMN, which is visual language that is standardized and widely adopted because it's very easy to read, but it has a major disadvantage because it doesn't allow to specify data processing. Second, there is BPEL, which is code-based. It is also standardized. It also supports various control patterns. In addition, it also supports data processing, but it is harder to read and, more importantly, it's discontinued. Finally, there are the emerging process modeling languages such as AWS State Language, Uber Cadence, and Netflix Conductor. They are also code-based and some of them lack visual editors. They have significant gaps in pattern support and some of them are running under the assumption of a closed ecosystem. So if we formalize the requirements for an executable model, we will end up with the following: efficient syntax, control flow support, data processing support, and event processing support. And if we evaluate the existing process modeling languages against these requirements, we will see that although some of the languages support some of the requirements, there has been no language so far that would fully cover them all. With these requirements in mind, we started to design FactScript. For the language control flow expressiveness, we took BPMN as a reference because of its support for majority of control flow constructs and high standardization. Regarding the data processing expressiveness, we built FactScript based on Kotlin to achieve type safety and general data processing capabilities. Finally, we strived for messaging and event handling expressiveness, such as in BPEL, which allows send, receive, and send receives behavior, as well as waiting and reacting to message and timer events. So we have developed FactScript, which is a process scripting language. Here we briefly discuss the constructing elements of FactScript. So a process designed in FactScript consists of three big parts. The first one is the API, which defines the message that starts the process and also defines the promise, being the message types that can be returned when the process ends. The second and the main part is the execution, which contains all the activities and events that are taking place during the process. And finally, there is the report, which signals the end of the process by sending a corresponding message to the calling entity. Note that the type of this message is the same that has been defined in the API. As already mentioned, FactScript implements the various control flow structures that we are used to from BPMN, and even some BPMN is lacking. The control flow elements of FactScript are described in more detail in the full presentation. FactScript is implemented as a domain-specific language based on Kotlin. Here we briefly discuss the architecture of FactScript. It consists of two high-level entities, the first one being IntelliJ IDEA. It has the FactScript modeler, which uses the IntelliJ's standard text editor and FactScript construct definitions to provide code auto-completion, spell checking, and syntax highlighting. It also provides the translator, which transforms the process definition in FactScript into a model suitable for the execution engine. It has the listeners, which are responsible for the event handling and the external tasks, because this is how the activities in FactScript are implemented from the point of view of the execution engine. The second high-level entity is the execution engine. Now it is Camunda, but it must be noted that it doesn't necessarily have to be, because FactScript by itself is not bound to any specific execution engine. But as mentioned, in this implementation it is Camunda. It uses the BPMN process model provided by the translator and provides the execution engine, which orchestrates the process instances, calls FactScript tasks and triggers FactScript events. In order to evaluate FactScript, we did a case study using a real-life business process, and we describe this process in more detail in the full version of the presentation. On this slide, we can see the definition of the process in FactScript. As you can see, it is quite compact. Also, in the very same file, we have the definition of the variables used in the process. We also have the definition of the message types of the messages that are exchanged during the process. And what is very important, that also here in process definition, we can directly manipulate our data. Based on this case study, we have evaluated FactScript against the requirements we have defined in the beginning, starting with the efficient syntax. First, we evaluated the grammar of FactScript based on different metrics such as number of terminal and non-terminal symbols, effort required to understand the grammar, and complexity of the grammar, and compared FactScript to different programming languages such as Java and Kotlin. And as can be seen, especially from the latter two metrics, FactScript is by far less complex than the other programming languages, which also means that it will be by far easier to learn. We also did a lines of code comparison with BPMN. The process that we have shown took only 33 lines of code in FactScript, with additional 27 lines for data types and variables and message types, which sums up to 60 lines of code, while the very same process would take 429 lines of code in BPMN. Although this comparison is not 200% fair because BPMN has a visual editor, it still provides the first insights. Regarding the other requirements, we see that FactScript supports all major BPMN constructs, thus satisfying the second requirement. It can hold different variables of different types and also directly manipulate them, which satisfies the third requirement. And it can send and receive events and commands, can include start and intermediary events, and also can include time and error events, which satisfies the fourth requirement. So to sum it up, in this work we defined the requirements for a process scripting language, namely code efficiency, control flow expressiveness, data processing support, and event processing support. To address these requirements, we have designed FactScript, which is a DSL based on Kotlin. We did a case study of a real-world process to evaluate our process scripting language, and in future work we will do a user study with developers. We will also implement another execution engine, namely AWS step functions, and we're also working towards putting FactScript on blockchain. Thank you for your attention. Please ask your questions and don't forget to watch the full presentation.